Ready to start, Camu?
I think we can slowly. I can see that there's some attendees. There will be more of them, or they will. Okay, some of the people are attending and joining the session, joining the room. So let me maybe introduce you a little bit. So
Sure.
welcome everyone. We have another session during the GroupBy conference, and our next speaker is Mala. Mala is a senior database professional with over 20 years of experience working with data, primarily in SQL Server and related technologies. She has been volunteering with SQL Server community for the past 15 years and is also a recipient of the Passion Award for being an outstanding volunteer. She is a featured blogger on SQL Server Central.com and also blogs frequently at curiousaboutdata.com. She is an active on Twitter as CQL Mal. So thank you very much for submitting your session and presenting this to us, Mala. And over to you, actually, right now.
Thank you, Camille. Hello, everyone. Good morning, good afternoon, wherever you are. Thank you for joining my session. I will be speaking today on finding T-SQL anti-patterns with a tool called ScriptDOM. This tool has been around for a long time, but is not very well known. So I'm going to be showing you some usages of how you can use it to find anti-patterns. A big thank you to our sponsors. Every event needs sponsors to go on, and I want to thank IDERA for supporting community and making this event happen. A little bit about me, like Camille said before we started, I've been a SQL Server database engineer since 1996, mostly a DBA and then a database engineer for the past 4 years. I co-lead 2 user groups, the Data Platform Women in Tech user group and also the local TriPass SQL Server user group with Kevin Fiesel and Tracy Borgiano. And I'm found best way to reach me is on Twitter as SQLMAL. Today's presentation, we have a few takeaways. The first one is understanding what is this tool called ScriptDOM and why do we think it is useful. We learn how to create simple PowerShell-based scripts using the ScriptDOM to identify some T-SQL anti-patterns. We'll also learn to how we can fix some of these anti-patterns automatically. Then the pros and cons of this tool in comparison to other tools that we use for the same purpose. So let's start first with what are anti-patterns. Anti-patterns essentially it's a technique that's intended to solve something. It is created for a specific reason, but eventually it leads to other reasons. It's practiced really frequently, a lot of times, and it has some legitimate uses. So what we call anti-patterns has to fit these rules that we see here. And some examples are what I have outlined here, like select star is a very common example. The nolock hint is another. There are several that I have listed here. Now, anti-patterns, typically, they're not just rules that you can make a list out of. They may be very specific to the organization where you work at. Like, for example, naming standards. Your company may have their own ways of naming SQL Server objects, and those may be anything that does not follow that particular naming standard might be your anti-pattern. There may be some certain coding patterns that are very specific to your way of working. For example, where I work, we use query store a lot. So we have temp tables in stored procedures and in code that have primary keys that are not named. So when you force plans on these kind of stored procedures, then query store has a problem with that. So one of the rules that we have is that we should have unique indexes instead of primary keys on temp tables. Now, this is not essentially a rule that needs to go everywhere. People may not be using query store or it may not be relevant for you. So there are rules that are very specific to your organization, and there are rules that are generic in nature that everybody, follows. So anti-patterns, essentially, they are a combination of these two things. They're not just one list that everybody can follow the same way. It's Now, the part of the reason for a presentation like this is also that is because if you make a tool to find anti-patterns, or if you pull a tool off GitHub or something what somebody has written, you can see that a lot of those things do not apply to where you work. So I'm like, before I can blink, I have that thing gives me like 20 rules, and out of that 15 or 16 are not even applicable for me. So what do? I need to write my own. And that's how I went down this path of finding a tool that can do it for where I work, is teach me a way to write my own anti-patterns, my own code to find what is specific to my organization. And I hope that's the path that you can go down after you watch some of this, or you feel motivated to learn, is to make your own linting tool, or your own tool that can find what is not right in your code. So what are the options available if you want to find some of these anti-patterns? I'm going to list some of the options that we currently have. First one is a text-based search. Text-based search is very common. If you want to find, say, a nolock hint, you use the code search tool that you have, whatever you have, to find it. The second one is writing regex, creating a regex pattern to find something really, a bit more nuanced for a text-based search, maybe. Third-party tools, like I said, there are a lot of tools on GitHub and other places that you can find that allow you to do this kind of linting. And lastly, ScriptDOM, which is the one that I'm going to be talking about. Now, I'm going to list the pros and cons of each of these tools next. So with a text-based search, the problem with the text-based search is that it's going to find all the matches. Suppose you are using it to find a nolock hint, and somebody has put something with a nolock in a comment, like that person has said, no, I've introduced this hint, or I've removed it, or something. It's going to include those two. So a lot of false positives come with a text-based search. It's also not going to be very good at giving you the exact location of what it finds. So that the problems with the text-based search are again false positives and incomplete details. Regex. Now everybody who's used regex know it's a pain to write. So it's complex to construct, and you need to construct different things for different situations that you may need. So a lot of work, that's the main issue with regex. And oftentimes, one person has written it and another person is maintaining it, has no clue what this is supposed to find. Is this working correctly or not? All sorts of things. So that is the problem with regex. Third-party tools. Third-party tools, again, like I said, those tools are written for whoever, that person's place of work, whatever they think is the right anti-pattern for them. They may not be suitable for your specific needs, and you need upkeep. Maybe the last PR on that thing was like 3 years ago. Nobody's, taking care of it now, all those things. So these are some issues with third-party tools. What about DMVs? You can use DMVs to find a lot of these things if you want to. The problem is that, especially with the code search DMV, it functions the same way as your text-based search. And you can find other issues with objects and such. Let's say, for example, you want to find a setting that is missing in an index or something like that. You can use a DMV for that. But DMVs are specifically meant to find issues only after your object is created. So you want to find, let's say somebody is creating an index without a data compression setting on. You want to find that before that person's code goes live, before that index is created. Now, after you create it, it's possible to find it, but it's just a bit of a pain to fix. Depending on what your problem is, you may need downtime, you may have all sorts of other issues with it. Ideally, if you find that before that person rolls out their code, that would be great. So the problem again with DMVs is that you can only find issues after the object is created. So with ScriptDOM, the advantages it has over all those things that I just outlined is that it can find you the problems before that code goes live. It's a scientific method. It has it is a lot more reliable than your text search and things like that. It will not give you any false positives. And what is more, it's version compatible. So if you have something in code that is compatible with, say, SQL 2012, but one database, whereas you have a linting tool that works on SQL 2016, and it's going to point out all the problems with an older version as issues, whereas those things were okay for that particular version. So ScriptDOM, essentially, it is version compatible. It's not going to give you problems like that. It's not going to tell you that something that's okay for this particular version is a problem. So these are the advantages that you have with using something like this. And now I come back to what is this thing. ScriptDOM essentially is short for T-SQL script document object model. This was part of the, used to be part of the .NET Framework library. It's been around for a very long time, since 2008. And it's currently part of the DACFX package. So what can it do? ScriptDOM, essentially, it is like a Swiss Army knife. It can do a lot of different things. Essentially, some of the things it can do is to parse your T-SQL scripts and find any parsing errors if there are. It can format your scripts according to some general standards. It can find anti-patterns. Depending on what anti-patterns you're looking at, you may have to write code for it to find whatever that is. And it can fix some of those anti-patterns, not all of them, but some of them. So these are some of the uses. So when is this most useful? Like I just said, typically you want to tap into the power of something like this if you have a really large T-SQL code base and you got a legacy code that needs to be version compatible. You want to find, problems before they happen, not after. And then you don't want to stress your servers finding them. So these are some of the situations where you may find ScriptDOM really useful. And then installing ScriptDOM. Installing it is really easy. The link I have included here. If you search for the DACFX download on Google, you can find it very easily. So you just download and install that package. And there are separate versions for .NET Core and .NET Framework. What I'm going to be showing you is basically the version for .NET Framework. All you need for using this is this one library. So if you search for where SQL puts this library, the default path is something like this. This number depends on what version you have. But if you look for this and if you pull this DLL out and copy it to wherever you want it to run, it will run, and you don't need to have any SQL Server install or any such thing. So this is all it needs, is this one library to run. So the basic structure is that it's a huge namespace. This is the namespace. It has well over 1,000 classes. Every T-SQL construct is its own class. So that makes for a lot of different classes. Some of the important classes, the first one is the parser. Like I said, it is version compatible. So it goes all the way from 80 to 170. You have one for every version. Then you have what is called a T-SQL fragment, which is an abstract class. It is a collection of many different classes, and that's the abstract syntax tree. That's the one that we are going to be using the most. Then we have the fragment visitor, which is what is called a visitor pattern in the .NET world, visitor pattern implementation that is derived from this T-SQL fragment class. Then you have a script generator. Script generator is the one that helps you to format, and it is also what you're going to be using if you use this tool to fix whatever problems that it finds. And then in addition to all this, you also have several individual language-based statement classes, such as name table reference is one, select star expression is one. There are thousands of them. For every T-SQL construct that you can think of, there is a separate class. So there are literally thousands of classes. But the important ones that you need to be aware of are only this. And if you want additional, if you want to understand the additional classes, there is the Microsoft documentation is one way you can find it. You can also explore the syntax tree that it creates, and I'll show you exactly how you do that to find any of these things. So ScriptDOM parser, let's start initially with parser. What the parser does is, if you supply a script, then the parser is going to look for that script for syntax errors and tell you whether or not the script is syntactically correct. So we'll take a look at how this works right now. So here, this is an example of a script. Okay, so I'm going to show you, go one step further. I think it's the other one. Parse example. Okay, good. So I have a script here, and I'm going to introduce some syntax errors in it. Let's say I misspelled the set and declare, and then I will walk you through the code. Is the code clear, Camille? Is it too small, or can everybody see it?
No, looks good for me.
Okay.
Looks good.
Okay. So what you have to do is you have to add a reference to that DLL that I showed you. So you say add type here, you add a reference to the DLL, and then you create a new object out of this class. That's the T-SQL parser, which is the parser object. And then you create another object to hold the errors. If there are any errors, then to show it here. Then you create, separate the script that you passed into strings. Use the string reader object and pass, and then pass the output of that string to this parser, that is the parsed objects. And if it finds any syntax errors, it's going to show you that it has syntax errors. If not, nothing. Now, the important thing to remember here is that this is not going to verify your schema or anything. So if you misspell a table name or a column name, it's not going to know all that because it's not connected to any SQL server. All it's going to do is to check for syntax errors. So there it is. So it's going to tell you that it didn't like the declare, and it said, one more. If you go up a little, it said it didn't like the set statement. So it gave you those two things as error. So I'm going to fix these two things and run them again. So no parsing errors. So that's kind of what it does. Now what we are going to be working with is the output of this parser, which is what is called an abstract syntax tree. That's the one we are going to be using to find the kind of patterns that we want to find. What the parser essentially is just a way to verify if your code is syntactically correct. So if you have a lot of code lying around and you want to check if it's syntactically correct, this is one way to do it. All you have to do is to put a wrapper around this to loop through every file in your directory, whatever it is, and check if it is correct or not. And then it's going to do it for you.
Malan, one question. So actually you can do those things when you're building the project, let's say database project, yeah, if you have it.
What
Like SSDT, yeah? So if you have SSDT SQL Server data tools, if you're using that kind of database project,
yeah,
building that project also can, catch that kind of errors with the parser,
absolutely.
right?
Yes.
Mm-hmm.
Okay. So I'm going to explain a little bit to you about how parsing works. This is important because we are going to be using the output of the parser for future reasons. What the parser does is it has three components. The first component is called the lexer, and not to worry, all these terms look a little really cryptic, but it's really not half as hard as it looks. Really easy once you understand what it is. And if you've ever been to, a compiler class when you went to computer science school, you may already know this, but a lot of people haven't. So for the benefit of those people. So the three components are lexer, which creates tokens from the script. And I'll show you exactly what tokens are in a second. Parser, which matches the token to rules, and the syntax evaluator that spits out the tokens that, that are not matching along with whatever internal rules that SQL Server has. So it kind of works like this. So the text goes first and then goes to the lexer. The lexer splits out the tokens here. The tokens are sent to the parser. The parser builds what is called the abstract syntax tree out of it. Then this tree is supplied to the syntax evaluator, and the evaluator looks at it and says, okay, is this SQL Server syntax? Yes or no? Then it approves or it doesn't approve. That's how it works. So it's really not that hard if you understand how it is. Okay, so a couple of terms that I understand before I show you. What exactly is an abstract syntax tree? An abstract syntax tree is essentially a tree representation of the syntax. That is, each node of the tree, it represents how your syntax is constructed. And it's the output of the parser. So it's sort of like this. If you have a code like this, then you have a statement on top and you have different components of the code is like this. That is a DML, a DDL, an update, a select, and a commit, a rollback, and all these things, right? These are put into a tree-like form where you can query and find out which, which node has what, and whether something you want exists or doesn't exist, or things like that. So this is what is called an abstract syntax tree. Why do we need something like this? So people may be familiar with this kind of this common term, right? That when you have a sentence without the Oxford comma like this, the way you interpret it is completely different after you introduce the comma. So the purpose of the abstract syntax tree is like that Oxford comma. It helps you find the right things in the right place. And if you don't have it, you're going to be doing like what the text-based search does. You're going to be thinking every occurrence of something you're looking for is a problem. So the reason for this abstract syntax tree is to add context to the code and allow you to find the right things in the right place. Any questions, Kanu, so far?
No, there's no question so far.
Okay, now we want to explore the abstract syntax tree, right? Basic structure and how the fragment is created. And then I'll show you what is this thing called tokens and how they work. So let's get to both of that now. Okay, so what I have here essentially is basically it's a select statement. It's a use database statement. It's a select statement. Okay, and I'm going to parse the statement to explore what I call an abstract syntax tree. So each level of the statement and how it looks. So, okay, the second fix. Okay, never mind. Okay, I can still show it to you. So what this does is basically parse that select statement. And when you, what is the output of that parser? If you have a syntactically correct select statement, is something like what you see here. I'm going to pull this up a little so that you can see it a little bit better. So it is like this. Batches, each batch is what is separated by the go command. We know that. So there are 3 batches in this. The first one is the use database, right? This is the first batch. This is the second batch. So it has 2 batches here. As you can see, there are 2 lines under this batch. So it's saying 2 batches. And then it's telling you the length of the fragment or the length of the code that you pass. It has 1006 characters. It starts at line 1 and it starts at column 1. So I'll show you a little bit more into what it has. So if I say, so here within this batch, there is this one statement. The statement it says is an identifier. So you go a little bit further. Statement. So it says it's a database name, and that's how I know. If you go to the second statement, second batch rather, that is your select statement. So this one you can see that it has all the components of a select statement. Move this up a little bit more. So into, on, compute class with cities, all of this query expression into, like all of these are parts of the select statement that we just saw. So this construct is what we call an abstract syntax tree. And this is what we are going to be using to find what we want to find, the anti-patterns. Now I talked of tokens. Now what are tokens? Tokens, as you can see, the stream at the bottom of this is called a token stream. This token stream essentially takes every element of the code and it converts it into a token, each of which has a token type, it has a token text, and it has a certain value. So I'm going to show you an example of how that works. So very simple code here. We can do this here. Input. Okay, where one line statement, and then we do the same thing that I showed you before, and then I loop for tokens. I find what is the token type, and then location in the line, and there is also a function called is keyword that tells you whether or not that is a keyword. So that's how it works. I'll show you 1 minute. Okay. So it's telling you white space, line 2, column 2, is this a reserved word? False. So go is not considered a reserved word, it's false. So that's how it's doing. It's going through things like this, single line comment, and it's telling you what is a reserved word and what is not, and what does it call it, right? It calls comments a single line comment. Same way, if you have multi-line comments with the hash star, slash star, it's going to do that too. So that's how it's useful. And what are the use cases of this? Like, it's useful to find problems, like if you have a rule that tells you all your reserved words have to be capitalized, then it's useful to find things like that. Or if you have a rule that says nobody has to use short forms of words, like for example, tran instead of transaction is not allowed. So you want to find exceptions like that, then using tokens comes in very handy. So that's the use case, and tokens are there at every level of the tree. As we go down, as we saw, you can find it at every node of the tree, like what is the word, what is, all these properties can be found. Okay, so we saw use as a, okay. So the next thing is to use it as a formatter. How you can use this thing to format your code. Let me show that too, and then we can go on to the other things. Okay, format T-SQL. Essentially what it is that the formatter is that it has certain options. Okay, it comes with standard options. It's not anything very, I wouldn't call it very flexible. So you pass to it a script, and then you do the same thing that you did. You use the parser to determine whether the script is syntactically correct. And then you create what is called a generator object, which is again part of the ScriptDOM. One of the classes is called a SQL generator. So you create an instance of that. And then this generator object has certain options. So it's several options, like, do you want to include semicolons at the end of every command? Do you want to align certain things a certain way? Do you want to have keywords on their own, as if you have as keyword, stored procedure as, we want that on its own line, on and on. So there are a number of options like this, including the keyword casing and all of that. You set these options according to what your preferences may be, and then you pass the script to it, and then if you reformat it, it's going to format it in the way that you desire. So let me show you the code I have here. So I have some code here that has, that is a little shabby, you can say. So it has a create or alter in lowercase, and it's a little bit messed up. If you look down here, I have it, the select is or not, it's all misaligned and stuff like that. So I'm going to try and format this right with the help of this tool. Do this, I go down. Okay, so we run it. Okay, so here we go. this is what it created. So if you compare these two things, you can see how the formatting has worked. So it is aligned. Everything right, and it is capitalized my creator alter and all of this stuff. So this thing is useful. There is one problem with this though, or rather there are two problems. One is that I don't like the way it lumps all the different columns together for the insert on the same line. So there is no option to take care of this. That is one problem. The second problem is a bigger problem, is that it strips your code of comments. Now, this is something that, a complaint that I have opened with Microsoft, but they haven't fixed it yet. So this might be a problem if you try and use it, is that the way this works, it tries to get rid of comments. This is not a good thing. But if you're not very particular about, you can see here, I had a comment here, that comment is gone. So if these things are not a problem for you, it's really simple and easy to use. But otherwise, it has a couple of issues that they need to fix before people can use it mainstream. So I have a complaint open on their GitHub. If you think this is maybe useful to you, please go and upvote it, help them fix it. So we saw how we can use it as a formatter. So far we saw three uses for it. We saw how you can use it as a parser. We saw something about tokens, and we saw how you can use it as a formatter. So 3 uses. The next one we want to do, which is the key use, is to find anti-patterns. That's the main reason why we have it. So that in order to use that, we have to understand what we call a visitor class. So I showed you how you walk through what it creates, the abstract syntax tree at different levels. Now, if I want to find something like that by hand, I have to write a lot of code. I have to understand how the code is structured and then go looking for whatever it is that I need to find. So to show you an example, let me see here again. We saw this, and we saw how, hold on. Never mind that, but we saw this tree that it created. Now, if I wanted to find something with this, I need to go down one by one, at each level, unpeel it like an onion and see how I have to find. So an example here I have is a select star in the code. So if I have something like a select star here, the code I have to write is something like this. So I have to loop through each sentence. I have to check if the statement type is a select statement. Then I have to check if a column in the select statement is a select star expression. And then I pop an error saying, hey, I found a select star here. So if I run this, so it found a select star for me, and it tells me that, whatever I supplied here has a select star in it. This is one way to do it, but this is for one statement. If I have this much of code, imagine how much code I may need to write for a stored procedure or for a function or something that's really voluminous, not practical, too much. And also, people write code in a bunch of different ways. I may not even be able to know how they wrote it and walk through it the right way. So this is not really feasible to do. I need something more efficient. And what ScriptDOM has in order to make that simpler is what we call a visitor class. Now, a visitor class it's actually a .NET design pattern that they have used to make this process simpler. Now, if you have to manually find all your nolock hints or your select star expressions, you would be doing something like this, like picking these apples by hand, like this person is doing. You may miss some, it's very possible that you may not be able to get to all of it. It's going to take a lot of time, and it's very painful. Now, if you walk the abstract syntax tree, like I just showed you, that is a little bit like this one. So like this kind of tool this person has is you go and shake every branch and you get the apples out of it. Then, yeah, it's more efficient than the one we have to the left, for sure. But again, this is also very time consuming, and it may not get to all the apples like you need, because you may not know all the different ways people write code. So again, easier, but not the best. Now, what is really efficient is what is using the visitor class. That works a little bit like this. So that is a machine that goes and it shakes the tree of all the apples. So chances that it's going to miss something is really, really, unusual. This thing might miss something, but the visitor class really doesn't miss anything. And it's super easy to use. It's easy to use, and you'll see how it works. So the next thing is using ScriptDOM efficiently is called a visitor class. Now, a visitor class, essentially, it is derived from this basic, what is called a T-SQL fragment visitor base class. And this has what is called a visit method, which defines what you do with when you encounter a certain type of class. Now, this might sound a little bit, hard to understand. So I'll show you how this works. Second. So let's look at something. Say you want to find a nolock hint. The difference between finding it the way I showed you and the way like this. What this is the output of the parser. So you parse the output of the parser here, and then you define this class. This class is what I called a visitor class, which is based on the T-SQL fragment visitor. And here you have the visit method, to which you pass whatever that fragment is, you pass it. And in this method, you look for what you call a table hint. So there are a number of different things based on all the constructs of T-SQL. There are a number of classes like this, and you have to find what is the right class you have to use for what you're trying to find. So I'm trying to find a table hint. So I tell it to go find a table hint. It will find all the table hints for me. So I go and check if the hint I want is the nolock. So if the hint kind is nolock, then I pop an error saying I found the nolock. And how I use it is I create an instance of the visitor class, and then I call the accept method and I pass this instance to it, and this is the output of the parser. So if I run this for you, I'm going to do linting errors. Let's see if I've commented out everything here. That's literally also all I'm doing here is I'm doing the same thing that I showed you before, is creating an parser, output of the parser, and I'm parsing the parser to find the visitor class. So okay, now call this. That script I have above, it has some nolock hints. So I'm going to expect this code to find all of it. So here it is. So it tells you that it found the nolock hint at this line, at this column, and this is the length of what it found. Really easy, really simple to do once you understand, get your hang of how this works. So this code is just, less than a few lines, and it found everything for you, less than 20 lines. And it found everything for you where it found. You don't need to write any extra code, no matter how many nolock hints you have. Now, another thing that we can look at the same way is a 4-part name. 4-part names are linked server references. If we are DBAs, a lot of us don't like linked servers. And if somebody's writing code that uses too many linked server references, we want to find them before that code goes live. So what I do here is, again, create another visitor class. I say I want a table reference with alias. That is the class I use, because you want to find a 4-part table name. So here you check if it has a server name included as the reference, then you say, okay, here I found the linked server reference. So let's see how this one works. So it found there was one link server reference there on line 34. So it told you that this table orders here. Here it is. This is what it found. It's telling you that it found that reference. Another example, a really common one, is a select star expression. Same way, you just say that you want to find a select star expression and you pass it the name of the class that you find and you pass the object, then it will find that for you. So it found two instances of select star from the above code, both a line, line and column. So like I said, very scientific. It will tell you the exact location of what it found, line, column, and everything that you need to know. All the information that you need to know is included in whatever it finds. So that is one that found line 55, and there is one above that line 33. Yeah. So the two select stars. So these are a few examples of how you use the visitor pattern. Another
Mala,
thing.
there's one question.
Yeah.
If we can. So Damu is asking, is there a way to find and replace in all the files where there is for-part naming happens with a different server name using this?
Yeah, absolutely. You can, it doesn't care what your server name is or anything like that. It will find anything for you. The only thing you have to do is to put a shell around this for it to run through your folders wherever you keep your scripts. Create a loop and make the same script run across every file you have in that loop, and it will find everything for you. It doesn't care what your linked server is or anything. Like I said, it doesn't connect to any SQL server, so there is no schema validation of any kind. So yeah, absolutely, yes.
I would change this question a little bit, Mala, if you allow me. So is there any like a PowerShell module, maybe with some commands that allows you to just check all those rules that you have already presented?
These scripts are in my GitHub repo. I can post the link soon as I'm done. If you want, are you asking about the script to loop through all the files in the directory? Is that what you mean?
No, not particularly. But
I can give you the link to this.
Another question would be if you are sharing the code that you're presenting. But actually, I'm just wondering if there's any, like already PowerShell module, maybe that you can just install and import, and then run some specific rules against the set of the scripts.
Not yet. I haven't created
something like DBHS, something like DBA tools, something like that.
Right. I understand. So part of that is I'm working out with my employer because I wrote this tool for them. So it's close to approval. Once that is done, then it will be published on our company's GitHub repo. Right now, all I have is individual scripts. So don't have a module to share yet. Sorry, but it's in the works.
Okay.
Yeah.
Yeah. Thank you. Yeah. That's great.
So another example I want to show you is to find reserved words. Like we talked about tokens a little while ago. So why do we use tokens for? We use tokens to find keywords. One of the uses for it is to find keywords that are not in the right case. So here, what I'm doing is I'm taking the token, checking if the token is a keyword. This is keyword function is also inbuilt. So it will tell you if it's a keyword or not. Then I check if that word is in uppercase. So we show you how this one works. So there are two keywords that are not in uppercase and it found them for me. So that's an example. Okay. So let's go back. We saw what was the visitor class and how useful that is to find various patterns in the code. The next one, or the last main important use, is using ScriptDOM to fix what it finds. So fixing it, again, it involves using the output of the parser and then the visitor class to find whatever you want to find. And then the formatter, which is what we saw. You write the appropriate syntax for it to remove or add or whatever you want it to do. And then use the formatter to reformat it without whatever you want removed. So what I have seen personally is that this is really, really useful in scripts. Like I said, the disadvantage you have with the formatter is that it strips the code of the comments. But if you have a scenario where you have table scripts or index scripts which really don't have any comments on them, then this can be like really useful to fix things like missing index settings and stuff like that. So I'll show you an example of some of the uses of this thing. So let's look first at fixing the nolock hint. So what it is, it's the same thing as finding it, except that in this case, what you do is you invoke the remove method and you say, remove this hint because you thought, this hint is this kind. It will remove it without causing any other kind of damage to your code. Okay. Sorry. So another problem thing also with the nolock is you can invoke nolock with the setting, right? Set transaction isolation level, read uncommitted. You want that setting also removed. So what you're doing is to change that setting from uncommitted to committed, which is fairly benign, harmless. So that's what this code is going to do, is to fix those two things: remove your nolock and also change that setting from uncommitted to committed. So I have a proc here. I show you what proc with nolock. Let me show that first. I'm going to delete the output. Proc with nolock is like this. I say here I have a set transaction isolation level, read uncommitted. Now this is just a demo, so I'm doing both. And there are some, believe me, there are some people who are paranoid and they have both in the code too. So you have, I have nolock here, and I also have this setting, and I'm going to see how I can use ScriptDOM to remove both of those things. There is a nolock here. You can see here, there is one and there is one here. So okay, so I go here and I compare these two things. I can see that it changed uncommitted to committed. And then if I go down further, the nolock is gone. So the advantage of doing this over, if you have a large volume of code and you want to get rid and clean it up of all the nolocks, this is very dependable to do. It's not going to change anything else for you. It's just going to go straight to what you asked it to do and clean it up and come out. So much easier and much more dependable than doing a text replace or any such messy things. There is not going to be any syntactical errors or anything involved. So that is one way you fix it. And then this one, what I said, like I said, indexes, right? The problem with that approach though is, again, if you have comments in the code, it's going to go after those comments. But you just have an index, let's say an index that is missing a data compression setting, which is important for you. So I have an index statement like this, just a create index statement, and it does not have my data compression setting. I do not want the programmer to push this out into my environment, because for me to come back and fix this is going to be a pain. So I want this fixed as soon as the code is written before it goes out. So I use something like this, and it's a fix it, and I tell, I want to add this data compression page. What I do up here, see here, index setting value, and then you accept, and then regenerate that whole thing with the new, with whatever you added. So the generator is the same thing that we showed you before. Then you do this. So it tells you that the data compression page is missing for this, and then it's fixing it. So if you go back here, compare these two. So it's added that. Really easy. And you can add any of these settings. That was just an example that I used. You can add settings. You can add other things too, like, if you're missing a primary key, or somebody is using a primary key without a name, this sort of thing. Any problem that you find in your script that may not be according to your standards, you can fix that. So we saw all the overview of all that this really powerful tool can do. The next one is some of the pros and cons, especially of fixing. Advantages are that it's really scientific. It's not going to mess up anything in your code. Really, really easy, dependable to do. The amount of code you have to write for it to do this, really short, efficient code, just a few lines of code. Cons, some of the cons is that it reformats your code. Like I said, some people are very picky about tabs versus spaces, or where each thing could go. That might be a bit of a problem. And if you use it on procedures and functions, it still removes comments. This is something they promised me that they're going to fix. It's not yet fixed yet, so we'll have to wait and see. The last one is also whatever specific fix you need. That may need some effort to figure out. Part of the reason why this tool is not used a lot is because the documentation around it is like really, really bad. They only have some automated documentation here. So the fix, that whatever you need to do, it's a lot of experiment, try and find out what is the best way to do it. Once you get the hang of it, it's really not that bad. But it takes time, because there aren't that many examples or blog posts or things that you can grab right away, and it may take some amount of effort. So these are some of the cons of fixing code. So pros and cons of ScriptDOM itself is that it's a really authentic, it's a scientific method, super easy to deploy and maintain. You have your own linter, and you can create whatever rules you want that are very specific to your environment. Really, really easy to do. It's asynchronous. It's not, you don't need any kind of connection to SQL Server to run it. Super easy. Your DBAs are going to be happy about that. It's backward compatible with any version. It's not going to gripe that something that was okay in that older version is not okay now. That sort of a problem you're not going to have. And you get to define your own rules, which is really, really cool, because no two companies have the same anti-patterns or the same linting rules for it. Every place is different based on whatever it is. There are some cons though. If you have a really, really large script, then the memory footprint on this can be very large. That is, the amount of memory it needs is about 2 gigabytes address space for 15 megabytes. A 15 megabyte script is a really big script, by the way. But you don't want to do crazy stuff like script out your whole entire database and throw it at it. That kind of stuff, don't do it, because it can eat up your memory like really, really quickly. With smaller scripts, not an issue. You're not even going to notice it. The parser is single threaded, just like it is with some of the other utilities that Microsoft makes. You have to resort to some sort of clever programming if that's a big deal, and if performance is an issue. It wasn't where I worked. It was barely noticeable. But if that happens to be an issue, that's because it's single threaded, and that's how it is by design. To change that, you may have to resort to some clever programming, and it needs some .NET programming knowledge. In fact, I would say if you are a DBA, like I was, an operational DBA who's not comfortable at all with programming, this is a useful way to get started, to understand how object-oriented programming works and things like that. A really easy, quick way to do that, but it needs some effort and some some understanding of a .NET programming language. So those are some of the disadvantages if you want to use it. There, if you have a really nuanced situation, like you want to find a very specific situation in code, that might take usage of multiple visitor classes and some amount of programming effort. It's not going to be like really quick, but depending on what you need, you may have to work it out really hard. And the formatter, like I said, the formatter not retaining comments is a big pain, and that is something that they really have to fix if you want to use it to either format your code or to fix the problems that it finds. You can still use it as a linter without that. That's not a problem at all. So these are some references that may come in handy for you. There aren't too many blog posts on this. I'm writing a Stairway series at SQL Server Central for Steve Jones. My third article in that is going to go out next week. There was an MVP named Dan Guzman. His blog is very useful. Arvind Shamsundar, who is the Microsoft PM for this product, he has some talks on it which are like fairly old, but they're still worth watching. Aaron Bertrand has written some good articles on MS SQL tips for finding some nuanced patterns. Those are pretty much it. And I have given a couple of podcast interviews and also spoken at a couple of events on this, like the one here. So the links on that are also included here. That's pretty much it.
Thank you very much, Mala.
Sure.
That's fantastic, great presentation with very well prepared demo. Thank you for that. So in the one of the latest slides, you showed that the .NET language is a little bit like required for these things, but I saw a lot of PowerShell scripts that you presented, and you use PowerShell's language actually a lot. So which skills is much more useful in this topic?
I'm not sure I understand, Kamil. What would you mean?
So you showed a lot of PowerShell scripts, yeah, when you're running the demo, yeah. So, but you said on one of your slides that the .NET skills is also required for
yeah,
for
right. You have to be able to. You can do whatever I did here using VB.NET or C# or anything, any other tool that can go into .NET framework. That is fine. Now PowerShell essentially is really easy for DBS. That's why I chose PowerShell, and deploying a PowerShell script is so much more easier. So you can do it using any other .NET language. That is also totally fine. Whatever may be your choice. The library is the same. The usage is the same across any of them.
Yeah, that's right. Thank you very much. And Mara, do you share the slides and the code somewhere right now?
Yeah, I'll post. I have all of that on my GitHub link. I will post in a second. Would I have it here? Don't have it here. I thought I had the link here for some reason. Oh no, I do have it here. Okay. Click. Here. Yep.
Thank you very much. ScriptDOM presentation. Yeah, great. Fantastic. So we can find we can find the presentation that you already showed us and the code, right?
Yes.
Fantastic. Thank you very much. Is there any other question, guys? You would like to ask Mala right now? It's comments like awesome session, Mala. As always.
Thank you. Ramu, yeah, he comes for all my ScriptDOM sessions.
Okay. If there's no other questions, I believe that people can reach you out, Mala, via Twitter, probably.
Yeah, and my
If they
Twitter
have.
tag is at.
Yes, I've already, at the beginning of the session, I
Yeah.
paste the link to your Twitter account, to your Twitter handle.
Oh,
Yeah.
I'm sending to hosts and panelists. Sorry.
Yeah, that's fine. That's fine. Absolutely. Okay. I can't see any other questions, so I think we can finish the session right now. Thank you very much, Mara, again, and have a great afternoon.
You too. Thank you.
Thank you very much. Take
Bye.
care. Bye-bye.